expensive, like thousands of dollars, if you don't have a license for them, or if you want to buy a license. As well, these softwares do not have 3D printing capabilities easily with them. And in basically almost every area of education now, there's an emphasis on 3D printing. As everyone knows, there's a 3D printer over there. So in order to combine these two ideas, an idea of a computer algebra system that is free and easy to use, and you can use anywhere on browsers or on your smartphone, if we combine that idea with the idea of 3D printing and easily integrate them, then that will be a very worthwhile educational tool or an educational goal. So our lab is famous for developing a lot of these SAGE tools that also have 3D printing capabilities. So what I've done specifically is extended on them and also made some other additions that were separate from them. And the three main areas are, here in blue we have the miscellaneous grapher tool, and which is sort of, it can do various functions that I will discuss later. Also, population modeling simulators, which is a personal interest of mine. I've always liked mathematical modeling. And then a plethora or variety of tools that can have STL file generation capabilities. And we've actually made some for almost every level of education, for elementary school students and middle school students and me and instructors and everyone. So it's a very noble goal, I suppose. But I think, so those are the three main areas that I've created, and I want to introduce them all to you. So, okay. So as you all know, universities in general, but also our university and Korean universities, have made really, really great efforts in providing online material for students. These include video recordings, lectures, interactive materials, notes that you can see before or after class time. And these have been proven to increase students' education and increase their scores and increase their overall learning capabilities. So as well, there is a growing body of research for video games being connected to math and science and engineering education, which might seem kind of strange, but it actually was said, I don't know if you know NPR, but there was a lot of talks about how video games, if Euclid's Elements was made now, it would probably be a video game. Like the visualization and also just this content matter can really help to develop a mathematics education. So technology tools in general, with obviously the growing technological environment, it seems sort of natural to try to make tools that encompass or the ability to use technology both inside and outside of the classroom. If you use MATLAB or Maple, you can only use it at one computer, and you have to pay money to change the licenses. So there needs to be, especially in Korea, there needs to be more of an emphasis on the fluidity of technology tools in the classroom and inside of the classroom. Okay. So here, we actually designed, as I said before, we designed resources with SAGE, which I will not go so much into, but it's based on Python, and Python was the first computer language that I learned, so I think it's very special. It's very easy, but anyway, you don't have to learn Python for students who just want to use the tools. And we've made many tools that have been discussed in other research areas and in other papers, such as the SAGE Grapher, which just graphs functions, three-dimensional functions, parametric functions, implicit functions, et cetera, and other 3D printing tools that follow those guidelines. Am I talking too quickly? Yes. Okay. It's not a race. Okay. So as I said before, the three main areas are a supplementary graphing tool, which I will show you, and that will be graphing two-dimensional and three-dimensional points, and more basic graphing capabilities. There's also a matrix norm calculator and modeling simulators and general 3D printing SAGE tools on a website that we actually used for a competition and I developed. So that's what I will show you now. And the educational importance of these tools in general is the fact that classroom environments now are so fluid and they're so adaptive that it doesn't seem natural to use software for mathematics or use textbooks that can only be had in certain places or only be utilized in the classroom by one person, everybody watching them. So the idea of the flipped classroom, which is a very, very popular educational trend, especially in mathematics, the flipped classroom will put material online, and then the students are first introduced to the subject online, at home, anywhere where their computer is. Then after, they go to class, and class is used for reinforcement or projects or discussion. And that now is a very, very popular educational trend in America, especially in America, but elsewhere too in Europe. And tools where a student can use them on their smartphone, they can use them in their house, they can use them at McDonald's if they want to. Those are really, really important and work really, really well with this kind of idea because of their ease, the portability, and the user can interact with them whenever they want. So, as I said before, there were a lot of barriers. Everything in blue is kind of important. Blue is my favorite color. So, there are language barriers associated with the large software packages and the money, obviously, because I don't have money and no one has money if they are a student. But, so you had to, Sage was developed, this language, to do mathematical computations without having to purchase, download, install, and then learn MATLAB code, which MATLAB code is important, but it's another code you have to learn if you already know something. So instead, you can actually embed this HTML code, which puts Sage cells, and Sage cells are kind of like on a web page. I mean, I can show you, they look like this. This code here, and you can directly edit anything you want, and this is within a web page. So if you want, you can show this directly to the students so they can edit it, or you can hide it, but they can still view it because it's always open source, but it's just how much you want them to be able to edit. So this is how you embed a Sage cell into a website. And then from here, that's how all of our tools have been developed following these guidelines, especially our Sage Grapher, which I will not go into detail because I didn't develop this. But as you can see here, this is, you can edit, this is for just a general function, but there are various different kinds, like implicit, parametric, polar, and picture, blah, blah. So you can either edit, or you can either input a function directly, or you can just use the function and then alter or change the coefficients depending on whatever you want. So you can create two-dimensional or 3D functions, and then also you can 3D print them, which I will talk about later if I ever slow down. But okay, so what I have made is actually a sort of miscellaneous graphing tool, which does this function. So these functions here. So instead of doing like a function with an equation, you can plot distinct points, either in two-dimensional or three-dimensional space, and you insert them here as arrays. Or you can, instead of using an equation, you can actually physically input points, three-dimensional points, and then a surface will be generated based on the points that connects all of the points that you made, which before there's really no algorithmic way to do this, so that is a possibility, and it's a lovely color. There's also a ruler function, which just you can see points based on certain increments, and the user does not have to understand the code behind it. They can just change the coefficients depending on whatever they want, and now it looks kind of strange. But so as well, you can see regular polygons and change them depending on the number of vertices. And you can also, so what's of note here is platonic solids, and which are polyhedra with regular faces as polygons, or regular polygons as faces, and then Archimedean solids. And why this is actually important and is fairly interactive, not only for mathematics education, but from a young age, we are familiar with, especially platonic solids, we're familiar with them. So you can be in elementary school and view something like this, and you understand, oh, all sides are equal. And they sort of, I think, as it was stated, that Platonic solids especially, these solids are the building blocks of existence. They encapsulate our understanding of the universe. Plato said they were ideal solids. So, yeah. Mm-hmm.
By showing this, you were not claiming that this is built by this.
Oh, well, I made this. Yeah.
And also, we made all this new environment.
So this yellow part is developed by you.
Yes.
Can you drain us?
Yeah, sure. You want to see there's more interesting code than this, or these particular ones. But I can show you.
Make a copy of the whole comment.
This one?
Yeah.
Okay.
And
Put it in
put it in the
Notepad, maybe? Word, but okay. So yeah, I can explain then a little bit. Now it's a little bit harder to read. But this is programmed in Sage, and all of the code was made by me.
From now on, it will be better if you emphasize what you actually did.
What I did? Okay. I did everything.
That's cool.
So yes, this was code that I made, I suppose. And what it does is, I don't know how much you want me to say, but here is basically this is what makes it interactive for users. So you, according to whatever you click, it will run certain code that will do certain functions that you want. So there are built-in functions in Sage that do certain things. Like, for example, you can define, like, okay, a tetrahedron and then a cube with certain parameters. So luckily, certain things are actually pre-developed in Sage, but they don't have the interactive aspect of them. So as well, they have, so that, I want to discuss this different thing later because that's actually kind of important. But yeah, and then certain things here, as in implicit plotting of three-dimensional curves, depending on whatever the user input for points, you can create the curve, and then here is when you actually create the STL file, which an STL file is is the file used for 3D printing and how 3D printers interpret three-dimensional objects. So this is the function that does it. So that's what all of our, yeah, go ahead.
So this STL file it's already there, or it's also
we made a code.
I can explain that actually. So what an STL file is and how the code's been developed. STL file is you basically assess an object as a collection of triangles. So it takes surfaces and then it makes a collection of triangles based on their normals and their vertices. So what the code in Sage does actually here is, or I have that written on my paper. Hold on. It's a little bit later. So the code here, what you can see that this, our lab developed, I did not personally develop this code, but we've used it in all of our tools. Yeah. Which is really amazing, actually. So as you can see here, it assesses any surfaces that you give it as input as a collection of triangles. And then here, after you view a surface, it will take all of that information and it will create an STL file for it. So if you actually were to open and view the STL file on on Notepad, you would just see vertices, faces, face. So it would just be a collection of triangles. But that's how you view it and 3D print it. So all of our tools are based off of that idea. Okay. So the last thing that this can do, I should probably hurry up a little bit. So the last thing that this can do is, there's something I actually, in your class, we talked about the projective plane and dual curves. And as I was trying to study for that and understand that, because it was extremely difficult, I actually developed some code to take an implicit function, and then from that function, you can actually, this was not made, I made this code for Sage, but you can get the equation for the set of all lines tangent to the curve, and that's the dual curve. At least in 3 dimensions, it's the dual curve. So I made the code in Sage to be able to view and manipulate any function here, and then this is actually the equation of the dual curve that you can visualize, and then,
This is a curve.
well, yeah, it's not technically a curve, but it's the collection of all of the lines tangent to the curve.
So in your equation, it's the next image x squared minus y squared plus c squared.
Yeah, this is just a random one.
What is that?
That's the equation for this curve.
That's that's a hypersurface in three-dimensional space. It's
Mhm.
the surface, not the curve.
Oh. I guess maybe I could do more precise wording then. But the code that you can view is,
And also in your previous file, that f equals equation of curve homogeneous coordinate. That makes sense when you have 3 variables because it is homogeneous, but the equation you have is not homogeneous.
I don't think there's a way currently to account for homogeneous coordinates within Sage now, because that'd be accounting for points at infinity, which I don't really think is, but for just pure visualization purposes, hopefully this will suffice. So, okay, so after that, then, I went a little bit far. Okay. So as well, there is also there is a matrix calculator that has been developed by our lab already, which checks a lot of different properties. And as an extension to that, there's the properties of diagonal, if the matrix is diagonal, if the matrix is diagonalizable, which not all matrices are, and if it's not, we know that all matrices are almost diagonalizable and that they're similar to a Jordan canonical matrix, or the Jordan canonical form. And so with that in mind, I created this code here, which checks for an input of a matrix, checks whether or not the matrix is diagonal, and here it's not. It checks if it's diagonalizable, and here it's not. And if it's not, then it actually will calculate the Jordan form of the matrix, or Jordan block form. And what I would go into more detail, but I guess I can't. But obviously, if you have a matrix that is diagonalizable, such as this matrix, maybe. Oh, thank God. Okay. So this matrix is not diagonal, but it's diagonalizable. So it's similar to a diagonal matrix. And it will give you actually the similarity transformation matrix and the diagonal matrix as a result. This one is not very nice. The base field is algebraic numbers, so sometimes the results, if they're random, are a little bit ugly. But anyway, so that's also something that has been developed that could be easily added to our already growing matrix calculator and property checker. Okay, so then finally, I also have, okay. Going really slowly. Okay, so another thing, there has been a lot of modeling that's done. That's usually one of the main areas that MATLAB is used for, is mathematical modeling. And there are 2 big areas of modeling in differential equation, just ordinary differential equations. There's deterministic models, which are solutions to differential equations or partial differential equations. And then there's also stochastic processes, which I probably don't have to go into, but those are based just on random events that occur at discrete time steps. So that stochastic modeling makes a lot more sense in terms of like biological or bacterial colonies, or even like on the quantum level, because things are obviously more difficult to determine with an equation or a set of equations. So stochastic modeling was something that has never been developed in Sage. Like, there were no resources on it. So I actually went and read about resources that had been made in MATLAB, and because the capabilities of open source free software aren't nearly as much as they are as MATLAB, I had to sort of translate them and adapt them to Sage code and Sage tools. So I won't go into this in detail, but basically, just for a single birth and death rate, this is a deterministic equation for how, this is a deterministic model for birth and death for one species. And then this is the stochastic process, which will generate a random number, and then whether or not that's higher or lower than a certain thing, it will have a birth or a death. So I developed code based on the idea of interacting species and generating a random number, and then iteratively bumping that number to see what it's closest to see what event occurs, because there are 4 events now. There's prey birth, prey death, predator birth, and predator death. But obviously the predator birth and the prey death are dependent on one another, so it's not a linear interaction. But anyway, so I can show you this.
You have only 2 more minutes.
2 more minutes. Okay, so believe me, it works. But so yeah, here's a basic. This is in Sage, and here you can see the blue dots. As you can tell, it's not a continuous curve like a deterministic equation. It's stochastic, so it's inherently noisy, and that is the result of the code. But okay, and then I guess I won't talk about this enough as I want to. But another thing, I use a deterministic model framework to develop zombie population models. So I don't know if you're familiar with the SIR model of infection. So basically it models disease rates, which is really relevant right now. So instead of that, there's a famous model, or equation model here. So instead of SIR, it's SZR, and it's zombies, so the Z means zombies. And it's different from just SIR because zombies are created from people who are already dead. So that's why the dynamics for these models are not intuitive or not the same. So what I've done, and I actually made an app for it, because that's what cool people do. But I will show you really quickly, and I won't explain all the equations. Here, it's a mobile adapted site. Oops, exactly all of that. Wait, what's going on? Okay. Okay, yeah, so here's the mobile adapted site. Actually, I'll tweak a little. There's sound, but the music is really scary because it's zombies. Okay, so obviously it looks really bad now, but when you have on a smartphone within the app, it fits the screen really well. So you have 3 different, I won't go into all of them, you have 3 different kinds of zombie infection. You have standard zombie infection, and then you have latent infection and quarantine. So if there's a quarantine and there are zombies, how will that affect the dynamics? Will humans still die? Will zombies still win? The answer is yes, actually. The humans will still die. And then treatment for zombies where there's a cure, but if there's a high enough rate of infection, will humans live and will all of the zombies die? And actually, if you look really briefly at the dynamics of it, it actually almost always, here it's a little bit better, but almost always blues humans. No matter what you set the parameters to, almost always the zombies win and the humans die. The only way to eliminate them is by actually physically killing them with guns and stuff. So, yeah, and as an extension of that, just for like apocalypse math, there's what I spend a lot of my time doing, like different kinds of zombies and different zombie interactions from a really popular video game. And also the knapsack problem, which is a really famous problem in combinatorial optimization, where you have weapons, or not weapons always, but you have weapons, and you want to maximize the effectiveness of your materials while minimizing your weight. So using so I actually did like research on Amazon to see like how much things weigh, and then also like the effectiveness of certain weapons if you were to be in a zombie apocalypse. You want to kill a zombie with a chainsaw, but they're heavy. So what you actually do here is I put in all of that information, and then you can enter your weight in kilograms. So don't tell anybody I weigh 49. And it will tell you your ideal weapon setup. So for me, it'd be one pistol, an AK-47 would maximize the effectiveness and be the easiest to carry. So if I weighed 68, then it would be a pistol, pump shotgun, M16 assault rifle. So that's an optimization problem. But yeah, so that is something that also was created and is kind of fun and will hopefully increase interest among students, among anyone who's learning these sort of basic models of population. Okay, so then the very, very last thing I want to talk about is this is what it looks like on your phone. So the last thing is 3D printing with Sage tools. As I already discussed the code, but what's the most interesting thing about that is the library and the database that we have developed that has all of our content and a lot of functions that were made. And I actually made the website itself. So if I can find that really quickly. Okay, yeah, so if I go to this, and then, I don't know why. Internet Explorer is the best browser. Said no one. Okay. So this here is what we used during our 3D printing competition, and it has an extensive collection for all levels of most of these tools are developed by our lab, or developed by me, or developed by everyone. But so you can, if you are, for example, if you're in elementary school, you can see really basic, this is like a 2D to 3-dimensional stamp creator, and you can generate the STL files now the job's not working, but you can generate the STL file to print it. And this is actually something I made completely. Or you can see more basic shapes if you are in middle school, and then if you are in high school or if you're in university, you can actually use a lot of our functions that we've developed to view implicit or parametric or basic three-dimensional shapes. So it applies to a lot of different levels, and it looks really nice if you ask me. So that's also something that was developed, and I made the site. So, okay. So in conclusion, that was a lot of information, and I spoke really quickly, but overall, I think that Sage, in particular, has a lot of potential, not only because it's portable and not only because it's free, but because it's easy to use, and not just for students in Korea, but I think that if we continue to develop it and we continue to work towards making it have more functions, it could be just as powerful, even more so than MATLAB or Maple. And I think hopefully the tools that I've made have shown you that it can do a lot of weird different things. So anyway, thank you. In the end.
Okay, so you have used your tools for three-dimensional graph for PDs, deterministic PDs. And also you have used your tool for two-dimensional for stochastic ordinary differential equations.
Right.
Is it possible to use your tool for stochastic PDs?
I don't think there are no the resources right now on Sage, but I think you could, like before there were no resources on stochastic, just ordinary differentials.
Okay.
So that could be an area of research that could very easily be extended.
So the stochastic PDs are very important in real-world problems.
Mm-hmm. Yeah, and MATLAB can do them, but because Sage is still in its early development stages, there was no information on stochastic, so I had to translate code from MATLAB and adapt it and try to understand that. But easily you could move, the next step could be that.
If we develop some code for the standard problems on stochastic PD, then it will be okay to publish.
I think that's a big thing. Like, I mean, it's sort of, you can make your own collection of functions, but that would be like in Sage, you'd have to develop the code for them and then submit the collection of functions like they have for differential equations, like DE solve. It would be a separate class of functions you'd have to develop.
We have developed the code for most of the problems in engineering method.
Okay.
So yeah, we can after that project we can go further.
Stochastic PDs for these stochastic linear and non-linear.
Mm-hmm.
We have done for characters and linear development.
So there are no stochastic PDs in the
We haven't.
stochastic
Yeah,
PDs.
we see that.
I'll do it tomorrow. Just kidding.
She published 2 papers already, and what she have here, particularly the jumping models, the application of SIR model, is used, and also the tools that we use are totally different than in library. So it's okay, but she had some problem on presenting all those ideas because she was already employed 6 months ago.
I have a job now.
So she didn't have enough time to edit.
My job is actually design. I program now, and I design math video games for students. So it's really nice. It's actually it's a startup company in Korea. It's called Nori. You know Nori? You know it? Oh, okay. Yeah, like Nori. Yeah, it's an American and Korean company.
It's very popular, more popular in the United States. It's educational company, technology.
So basically your enthusiasm is on Sage?
My enthusiasm is on mathematics and making like the gamification of mathematics, which is what I do now in my job. So I really like programming, and so I want to program things that will increase interest in mathematics through games or just through interesting visualization. But my main love is math with programming and games. Yeah.
Also, it seems to me that you have been working so hard just against MATLAB, for example.
I feel like I hate it.
Any possibility for you to get hired?
By MATLAB? No, they probably hate me. I have my name on a list, never hire. My undergraduate research I used MATLAB for it, and so I'm familiar with it, but it's really expensive. Unless I pay $1 million or download it illegally, I can't use it. I think that's kind of a bad thing, a really bad thing, actually.
So what did you do addictive
This morning? Well, besides formatting issues, there were some issues with the matrix calculator, because I wanted to list both, if a matrix is diagonalizable, I wanted to be able to list the similarity matrix and then also the diagonal matrix that it's similar to. So a few things there. Also some of the format within the zombie models were not showing up correctly in the app. So that's what I tried to edit this morning.
There was some point that it should be replaced in the world with and also there's one big thing that you have to make a change here. You still use the math one as an address. When you publish it, it will be gone because I will refresh it. So you should download all those pages.
Okay.
And then you have to edit. I looked at this. The written in here is okay.
Right.
There's nothing wrong.
But the
here.
web pages.
We had to edit it, but I couldn't make any changes on it. That's why Professor Hall mentioned that there are some need of editing, wording on the web page. So you have to download it and make a proper editing, and then
finalize the format, yeah.
You should need to finalize it and upload it on the matrix web page, then change that address to here.
Okay.
You can give the web address before and then you can give the name.
Okay.
So directly, and then it will be passed after that working.
Okay, I can do that.
And also not before you correct my name.
Oh, did I tell your name wrong? I'm so sorry. That's an automatic failure. No, it's important.
You need to develop more on your communication skills. So when you before you finalize something, you have to double check, not just come with the final process. So it won't be done. It won't be done in that way.
Right.
So you can, is it okay or not? That you have to ask it. When you send these files, you said, this is the one that I'm using. That's not the way that
Okay, yeah.
the wording and things, so I can make a revision, so I can come with the
Communication skills.
the version that which is fairly okay.
Fairly okay. Good enough.
I'm fine. I'm done. Yeah. Professor Six, any comments? Then you may go.
Okay.
We may go wait outside.
Thank you so much. Close everything. Bye.
And also we have to thank the legal team.
Of course. Dude. Okay, bye.
The signature and date and signature. Date and the signature date.
Do you think she can pass? Yeah, for the master's level, yeah, her
Yes.
work is above the average. But she must be very busy in finding.
So she will not come to PhD course.
No, she got a doctorate, so she may later, but now she needs the money. And she's popular too. She's a journal model, cover pages, and her best friend is the one who we see in 기정상회담 in TV. Yeah, the American friend from New York, Chicago. He's his best friend. Yeah.
This is comment I have to write something. I recommend.
Write something.
I recommend also.
Recommend something or something you like. You like to ask her to make changes or anything. Anything.
That's
One
good.
two line will be fine.
Okay.
I think we need a student P number.
Yeah.
What are you doing?
That's P number.
Yeah, yes.
Fine. Victoria, you need to write your PIN number and mobile number. Here. 예, 그냥 저기다 주면 돼요. 조교, 우조교한테 그냥.
examination report를
예,
넣어서 써야 된다.
선생님이 쓰셔야 되는데.